Hey folks. Okay, well, what I want to do this time is walk through just a simple handcrafted tokenizer or scanner. So this is just going to be a really basic C program that reads tokens for a really simple language that we're going to make up here in just a second. So what I'm going to do is walk through the process that it follows and take a look at some of the actual C code and see how we go. So there is the plan. So first off, what we'll have here is a directory with a bunch of different stuff in it. We'll have the various source code files. So we'll have a tokenizer that's essentially just got the main routine in it. Most of the functions that we're going to use are in tokens.c and then a header file, tokens.h, that's also going to specify a couple of data types we use. Makefile for it. A bunch of sample programs written in the language so we can try out our tokenizer and see if it actually works. And then a couple of test scripts. One test script to run it on all of the good test cases, and one test script to run it on all of the bad test cases, the cases that have invalid source code. So this is the basic idea. I'll talk about the language that we're using as our source code language in just a second. I'm just going to run through kind of the vague structure of the program. So essentially the main routine is just going to call one function to read the source code file in and stick the contents in one big character array. We'll have a second function called tokenize, and it's going to expect to be given the character array as one parameter, and then a second array that's going to be the list of tokens that it's going to fill in. So as it goes through the character array, it's going to identify tokens and copy those into the token array. And then finally, if everything works out, it's going to print the list of tokens that it came up with. Now right now things are set up so that if either read source runs into a problem or tokenize runs into a problem, it sees an invalid token in there, for instance, then it just bails out and the process stops. So it essentially quits at the first invalid token. So this is the idea for the main routine, and what we want to do is take a look in particular at the tokenize routine and the read token function that it's going to wind up making use of. I think you'll find that the main routine is just basic C. Again, it's just a bunch of function calls and a couple of definitions. The read source, again, we're just reading characters from a file and sticking them into a character array, so that one's pretty straightforward as well. The print token, all of our tokens are just going to be character arrays, so it's just going through this array of tokens and printing out each one of them. So again, most of these things are pretty straightforward C. We'll take a quick look at them, but I'm not going to spend much time on them at all. Really, we want to focus on tokenize and on read token. But before I get there, maybe we'll talk about the language that we're going to tokenize first. So the simp language, as some of you might have been tormented with this in other courses of mine at some point, it's really basic language. Again, the idea is just to show an example of a tokenizer, so it's just got a few different kinds of tokens in it. It accepts constants. So these are going to start with an uppercase alphabetic character, and then they can have a bunch of digits, so like X123 or C2007 or something like that. So as long as that first character is uppercase. Variables will just be one or more lowercase alphabetic characters, so lowercase A to Z, one or more. Integers, just one or more digits. Floats are just one or more digits, then a decimal point, then one or more digits. And a few operators. There's an assignment operator, there's a modulo operator that's 2% signs, and then there's the usual plus, minus, times, and divide. So that's all that the language consists of. Again, what we're looking at right now is just the tokenizer. So all it's going to do is go through the program and break the characters up into tokens that correspond to one of these things, or throw an error if it runs into something that isn't one of these things. If you're interested in the grammar for the language, that's given as well. Essentially, the language just accepts a whole bunch of statements of the form variable equals and then some expression, where the expression is a combination of the operators and floats, integers, variables, and constants. So it's a really simple language, not a lot to it, but again, we're just trying to illustrate our ability to tokenize here. So couple of observations we can make. The set of token types that we've got here, for the most part, we can look at the first character of a token and know what kind of a token it should be. There's not a lot of overlap here. Constants begin with an uppercase character, variables begin with a lowercase character, integers and floats are the only kind of ambiguous one where either one of them could begin with a digit. And then the symbols are all pretty unique character-wise. They either are just a plus, minus, times, or divide, or the assignment, the equals, or it's a percent, which should be followed by another percent. So for the most part, we can look at one character and figure out what kind of token this should be if it's going to turn out to be a valid token. And then we'll just keep reading characters as long as this thing still looks like it's valid for whatever token type we identified. So that's something to keep in mind as we get into the rest. So I just want to go through a couple of the sort of overall structural things in the code, and then we'll take a look at tokenize and read token. So somewhere here we've got our directory full of information. Again, we've got a couple of test scripts, so test good for running the good test cases, test bad for running the bad ones. We've got an examples directory that's got all of the sample source code files in it, the make file for the beastie, tokenizer.c that's got the main routine in it, and then again tokens.c and tokens.h. So tokens.h has got the headers and the type definitions, and tokens.c has just got the function implementations. So we'll just take a quick look at Tokenizer first to look at the main routine. So nothing too exciting here. Again, it's basically just one big main routine. We've got a character array that's going to contain our source code once we've read it in. We've got a token list that's just going to be our array of tokens once we've filled them in. And we'll keep track of how many characters there are in the source code and how many tokens we've identified as we're running through it. So a little bit of the usual error checking. You know, if they ran the program incorrectly, then we'll give them an error message. But essentially, we want to go through, we'll call this read source function to read from the input file that they're specifying as a command line argument into the character array. If that goes well, so the usual set of error checking, but if that goes well, then we'll call tokenize, and we'll give it the character array, and we'll give it our array of tokens that's waiting to be filled in. And if that works well, it'll return the number of tokens. And then again, usual bit of error checking. It'll check to see if it returned a -1, meaning something went wrong, or if it returned a 0, meaning there was no tokens. And if we get past all that, then we'll call the print tokens function to just print out all the tokens that were in that we stuck in that array. So again, main routine is pretty straightforward. If we take a look at the tokens.h, just to have a look at our data types here. Again, for the most part, this is just giving us the prototypes for all the different functions, setting some maximum lengths for the maximum number of tokens will support, the maximum number of characters in the input, and the maximum number of characters in a token. So again, nothing too exciting there. Our tokens will simply be a character array. So we're not doing anything fancy here. We're just saying, okay, well, when you're going through, if you identify something as a token, it's just going to be an array of characters. So nothing fancy. Again, the read source function is just responsible for opening the file, reading the characters in, and sticking them in an array. Print tokens is just assuming that we've been given this array of tokens, just go through and print them all out. And all of the really interesting stuff is going to happen in the two functions tokenize and read token. So read token is going to take our character array and our current position in it. So somebody's going to have to be keeping track of what position we're in our source code. So it's going to take our source code array, the position that we're at, and a token that it can fill in. So this is just going to be one of those tokens from the token list. And it's going to start reading from the position that we're given and see if it can identify the next valid token in the input. Once it does that, it will fill in the token, right? Copy it in there, and then just return what position we wound up in the source array. So if it started at position 50, for instance, and we read a 7-character token, it's going to return position 57. So read token is the one that's responsible for going through and trying to figure out where the next token begins and ends. And if we were doing, if we're going to associate identities with the tokens, it would be responsible for doing that as well. Right now we're not doing that. So tokenize is essentially just going to start at the start of our source code array and start with 0 tokens in our list, and it's just going to keep calling read token over and over and over again until we've read all the tokens and hit the end of the source code. So it's pretty straightforward from a logic point of view. We'll just take a look at the actual code for tokenize and the actual code for read token. And read token is the one I really want to focus on. So let's take a look in there at our tokens.c. Again, read source. This is just going through, opening a file, making sure everything works okay, copying the contents into our source code array, and giving it a null terminator, right? Sticking a \0 at the end. Print tokens is just saying, okay, you give me an array of tokens, tell me how many there are, and I'll go through the array and print each one of them. So again, nothing too exciting there. The mod 8 here is just saying every 8 tokens print out a new line, so it doesn't all wind up on one line. So the ones that we're interested in are tokenize and read token. Again, for tokenize, we're given the array of source code, the character array of source code, and we're given this array of tokens. It's just an array of strings. We're starting off saying, okay, well, I've seen no tokens so far. I'm starting off at position 0 in my source code array. And end position is just going to be whatever position the call to read token says we got to. So if I tell read token start reading from position 50 and it returns a 57 when it's done, that 57 is going to wind up in the end position, just so I can keep track of where that token ended so I can figure out where to start from next time. We'll just figure out how big our source code array is. And again, what we're going to do is just keep over and over and over again reading the next token until we hit the end of the source code. So while our current position in the source code is less than the number of characters of source code we've got, I'm going to call read token, say here's the character array, here's the token that needs to be filled in next. So the first time around it's going to fill in token 0, and each time we read one more token it's going to bump that up by 1, so the next time it'll fill in token 1, then token 2, then token 3 in our array of tokens. And again, it's passing the position that we're starting from in the source code array. If read token finds an invalid token, it's going to return a -1, so if something goes wrong it'll return a -1. So if it comes back with a -1, we'll just bail out and say, no, sorry, you gave me a bad source code file. Otherwise, read token tells us where it stopped reading the token, right? What the last valid character in the token was, and so we'll update our position with that. So that next time we call read token, we'll start from where we left off. And again, we'll bump up our number of tokens if we actually got a valid token, or if read token actually found something valid. And we just keep doing that over and over again until we hit the end. And then we'll tell the main routine how many tokens we found. All right. And that -1 is just because we're actually going to get one extra token at the end from whatever white space is at the end. There's going to be at least one of them. So, no biggie there. I'm going to ignore the isop for just a second. It's just a little helper function. And what we're really interested in is this read token routine. So again, we're given the array of source code, we're told the position to start looking in, and we're given a token to fill in if we actually find a valid token. So I'm going to use end pause to keep track of where our ending position is and return it eventually. So end pause is where we are in the source code array as we're going through this. And this pause index is going to be keeping track of how many characters we've read for the current token. So essentially, this is the position that we're in the token that we're filling in, and this is the position that we're in the overall source code array. So first thing we're going to do is skip over any leading white space. We're just going to ignore white space for this and see if we can find the start of the next token. And so we'll just keep saying, well, while it's white space, keep bumping up our current position and don't do anything with it. The one thing we have to watch out for is it's possible that we hit the end of the input somewhere in this bunch of white space, right? There might be a bunch of white space at the end of the file. So if we do hit a bunch of white space, then we'll just return the position that we ended on. And otherwise, eventually, well, once we get past the white space, assuming we haven't hit the end of the input, then we want to look at that next character and figure out what kind of token this should be. So again, we can look at that first character. If it's an uppercase alphabetic character, it'll be a constant. If it's a lowercase alphabetic character, it'll be a variable, if it's valid. If it's an integer, or if it's a digit rather, then it'll be either an integer or possibly a float. And if it's one of those symbol characters, then it's that kind of symbol. So we've basically just got a bunch of if-else statements here that's saying, okay, well, if it's a lowercase alphabetic, right, if it's lower and alpha, then we'll treat this as if it's a variable. Otherwise, if it's alphabetic but uppercase, then we'll go through and treat it as if it's constant. And if it's a digit, in the beginning we'll treat it more or less as an integer, so we'll keep reading digits, but eventually if we run into a decimal point, then we'll say, oh, this must have been a float, right? So we'll keep going that way. And otherwise, if it's one of those single character operator characters, we'll treat it as that. If it's the percent, we'll treat it as that. And if it's anything else, then it's not a valid token for us, right? It's something that's not in the set of tokens we recognize, and so we'll print a message and return -1. So what we're interested in is what happens once we decide what kind of token it should be and how we get the rest of it. So again, how we get the rest of it is basically just read one character at a time as long as it still appears to be valid. Right? So we'll just keep going through, for instance, with the variables, it should just be a whole bunch more lowercase alphabetic characters. So while it's still a lowercase alphabetic, we'll add it to our token and bump up which position we're in, right? Bump up which position we're in our token and bump up which position we're in our source code array. And we just have to make sure that we remember to check for the possibility that we actually hit the end of our input. Right? Similar idea for all the other ones. Right? If we think it's supposed to be a constant, right? It started with an uppercase alphabetic, then we just want to keep going through, reading one character at a time, bumping up our position in the token and our position in the source code array, copying from the right position in the source code array to the right position in our token, and just keep going. Well, it's a digit. Remember, it's for our constants, they were supposed to begin with an uppercase character, but after that they were supposed to be digits. So we stored that character, and then as long as we see a digit, we'll keep going through the same thing, saying, okay, well, copy that digit into the right position in our token, bump up our position in the source code array, and bump up our position in the token, and just remember to check for the end of input. All right, so all of our cases are following that same basic pattern. Right? We just keep going as long as it still looks like it's a valid character for us. A valid character for whatever token type we're in right now. Right? So if it was supposed to be, if we saw a digit at the beginning, then we'll keep reading digits as long as we see them. And we're kind of thinking at this point that it's an integer. But eventually, instead of seeing a digit, we might see a decimal point. In which case we're going to go, okay. Well, in that case, we're no longer looking at an integer, we must be looking at a float. And so after we see that, right, we copy that decimal point across to the token, and then we go back to looking for digits because there's supposed to be a bunch more digits after the decimal point if this thing is a valid float. So we just go through this process, checking over and over and over again until either we hit something that doesn't belong in the token type we're in, or until we get to the end of the token. Alrighty, so that's the idea. Again, it's very straightforward. The only real complication comes in figuring out what our combinations of if-elses should be in our read token, right? How we go through and distinguish between one token type and another. What kind of token should we be looking at right now, and how should we be processing this? So if you think about it, in this particular case, what we've really got is we've kind of come up with a read token routine that's acting sort of like a simple finite state machine, where it's saying our first state, before we read any characters for our token, is we haven't read anything. We read that first character, and either we go into a state for an integer, or we go into a state for a variable, or we go into a state for a single character operator or a multi-character operator, or we go into a state for a constant, right? One of those 5 states, or we go into our reject state. And then for each of those, we look at, okay, well, what's the next valid character type? And we either wind up reading, let's say for variables, another lowercase character, in which case we stay in our current state, or we see something that doesn't belong there and we dump out. And so we really are coming up with a really simple finite state machine based implementation, even though we really we didn't approach it that way. It's kind of the way it evolved. So if we can come up with a decent finite state machine representation, we can come up with an efficient code base that's going to look something along these lines. It's just how we come up with the best way to encode that. So there we have a real quick and dirty C tokenizer for a simple language. What we'll do next is to start looking at more formal processes for going, let's say, from our original regular expressions for the language into developing and optimizing a scanner for it. So that's what we'll tackle next time around.